Hey everybody. While I was doing the giant purple plastic padlock, I noticed that the equipment that I was building to accomplish the mold that I had designed was kind of taking on a life of its own. And I did a thing that I do occasionally where I get distracted by a tangential project and sort of go down the rabbit hole on it. And sometimes what results is actually pretty neat. I had done vacuum forming before with the block of wood and a smaller vacuum, and I was sort of impressed and gratified by how easy it was to do. I thought I would build something a little more complicated for this project that I would have later on. And it came out really well. I'm really quite proud of it. I thought I would go over some of the manufacturing decisions that I made to design this manufacturing tool, because what I'm hoping to do is sort of a little more intense stuff than you would see useful with the plastic bucket or the block of wood technique. So let's talk about what it can do. The work area is about 12 inches by 12 inches, and the carriage on those rails is about 14 inches by 14 inches. The idea is that you use these clips to attach sheets of plastic, lift this guy up to the heating elements, wait for your plastic to reach appropriate temperature, and then drop it. The surface area down here is perforated stainless steel sheet, and the vacuum over here is a 6-gallon, 3-horsepower vacuum. I think I said 6 horsepower during my previous video, but nope. 3 horsepower, relatively inexpensive, very easy to acquire. The box here is just plywood and 2x4 cut into appropriate shapes and glued together with wood glue and a brad nailer. From this angle, you can see the top side of the upper portion of the machine. It consists of two 250-watt heat lamps and one 300-watt space heater and an adapter for the 1100-watt heat gun. I basically started with the heat lamps, had moderate results with styrene, added the heat element for the space heater, got to quite good results with styrene, and then needed the extra 1100 watts to get anything approaching respectable results with PETG. So it's just been an arms race between myself and heat and the thermoplastic properties of these materials. The inside of the box is lined with aluminum, and the upper portion is removable. I say aluminum, it's lined with aluminum foil. There we go, come on. There's the inner guts of it. I used a couple of different materials, Super 77 spray glue, aluminum foil, and a lot of patience, some silver, or some aluminum duct tape as well. And I have expansion plans. I would really like to get rid of this unfortunate business because it's just a little bit haphazard. So I'm going to add more heat lamps, clean up the wiring, get rid of the space heater. That's how it was built. Let's take a look at how it works. So you insert the plastic sheet into the gantry. You secure it with some binder clips. It's the sheet is a little bit larger than 12 by 12. It's 14 by 14. I rip it on the bandsaw, and then once it gets hot enough, you just bring it down on top of your mold part, your mold positive, and you get a nice, very high fidelity part. The surface finish transfers very well. So these experiments were mostly done with 250 watts on the heat lamp and the 300 watt heat space heater installed. This one went a little wrong because a binder clip came off and it flopped around during the drop. I think this might be the one that ended up being used for the backplate mold. It came out really well. It just sucks right down. Really the key thing is the temperature of the plastic. There's almost very few other critical variables here. If the machine is set up correctly, then the plastic being at an even temperature all the way across it. Since I had so much trouble with that, I tried forming things progressively. I talked about this a little bit in my video, and you can see here a little more of the process. You have to lay the flat sheet across your positive and then just chase it around. I hope everybody enjoyed that nice look at the back of my shirt. This is PETG, and it really worked out quite well. You get a lot of time with this stuff. You get to sort of leisurely chase the heat around. You can heat it for a long time without any degradation of the material, unlike ABS. it becomes very pliable. It's easy to work. It's easy to work in this fashion, and it's very gratifying. And it's fun to watch the corners all sort of suck in like that. The tape around the work surface, the downdraft table, is to just improve the suction for this progressive forming process, and to sort of make the target a little easier to hit when I'm dropping the gantry. This is ABS, and I am not really a fan of how this turned out. It takes a lot of heat to become pliable, and then if you add much more heat past that point, you will quickly begin to degrade it. It warps a lot as you heat it. I will say that once you, like if you are putting in the time with this particular process, it looks like ABS might give really good results if you go very slowly and carefully. It does become very pliable in the correct temperature range, but that's a narrow range. I am pirating small tool bins from Stanley. I will make as many as I like. This worked out really well. This is glass-filled nylon under styrene, and that little container can actually be popped on top of a stack of other containers. This is high-density polyethylene, which just, I'm not sure if it was the heat or the structure of the cup not being strong enough, or the vacuum being too strong, but it worked out. I ended up using that cup as a mixing chamber for resin at one point. So that is my homemade vacuum forming machine for thermoplastics. Thank you for watching. I hope you enjoyed it. If you liked this video, I might make more of stuff like this, so let me know how you feel about that. Thanks for watching. You guys have a great day.